This is number 6 in the 2022 free response question part of the exam. Okay, this is another power series one. All right. Function f is defined by power series f of x minus this blah, blah, blah. I'm not going to read it all. For all real numbers x, which the series converges. Okay. This looks kind of familiar. Okay, I'll just say that. But anyway, using the ratio test, find the interval convergence for the power of the power series for f. Justify your answer. Okay, so we go through the motions of doing the ratio test. So limit n goes to infinity. You're going to use this general term, okay? We can drop this changing sign because it's within the, actually, let's, okay, I'll write it like how I do it. I do it first and then we'll see if I get the points, okay? This is a sub n plus 1 divided by a sub n. Okay, so it'll be x to the 2n plus 1 plus 1, be careful with parentheses, over 2n plus 1 times, this is 2n plus 1, x to 2n plus 1. Okay, equals limit n goes to infinity. This is x to the 2n plus 3 times 2n plus 1. Okay, let's even be clear with some parentheses. Over, this is x to the 2n plus 1 times, this is 2n plus 3 over here. Okay. Properties of exponents, this would simplify to x squared, which does not depend on n, it's like a constant. Pull it out. Okay, limit n goes to infinity, 2n plus 1 over 2n plus 3. This limit is just 1. Degrees are the same, take the ratio of the leading coefficients. So this is just x squared times 1, okay? Which is equal to x squared, okay? So we need to set this less than 1 per the convergence per the ratio test. The ratio test says the result of the limit has to be less than 1 for it to be absolutely convergent, if you remember, right? So x is less than absolute value of x less than 1, okay? So we're finding the interval of convergence, not the radius convergence, okay? So let's start solving the inequality. We gotta check the endpoints, okay? When x is minus 1, we plug in x as negative 1 into here. What do we get? We get summation as n goes from so 0 to infinity should work, I think, right? Yeah, should be 0 to infinity because when n is 0, we get x to the first power, okay? So we plug in x as minus 1, okay? So we get minus 1 to the n, minus 1 to the 2n plus 1. I'll shift it up after I write it. It'll be 2n plus 1, okay? So how do we simplify this? Properties of exponents. So this would be to the 3n plus 1. Okay, so this is summation n goes from 0 to infinity, minus 1 to the, as I said, 3n plus 1 over 2n plus 1. Okay, does this converge? Does this diverge? Well, we can actually rewrite this guy a little bit, because just imagine, well, let's start plugging it in. N is 0, it'll be minus 1 to the first power, which is negative 1. When n is 1, it will be minus 1 to the fourth power, which is 1. Okay? N is 2, it'll be, this is odd. N is 3, actually when n is 2, yeah, this is odd. When n is 3, this is even. N is 4, this is odd. N is 5, this is even. So this is the same thing as summation as n goes from 1 to infinity. As minus 1 to the, it started off as odd, right? So n plus 1 over 2n plus 1. You can just rewrite it like that, okay? Now, let's use the alternating series test, okay? So 1 over 2n plus 1 is a decreasing sequence, okay? And limit as n goes to infinity, 1 over 2n plus 1 equals 0. So it converges by the alternating series test. Okay? When x is 1, the other endpoint, we get summation as n goes from 1 to infinity, minus 1 to n, times 1 to 2n plus 1 over 2n plus 1. Okay? This is summation as n goes from 1 to infinity of, this is just 1, right? So it's just minus 1 to n over 2n plus 1. Okay? So this also converges by the alternating series test. Okay, 1 over 2n plus 1 is a decreasing sequence. I'll just write it all over again. Limit as n goes to infinity, 1 over 2n plus 1 equals 0. Converges by alternating series test. So the interval of convergence is inclusive of these two endpoints, and I would box that answer. Okay? Okay, so let's see the scoring guidelines. Let's see what was required, what was not, and did I get all the points, okay? Sets up ratio. Do I need to have the minus changing sign? I'm trying to read the scoring guidelines. Give me a moment. Okay. The correct ratio with or without absolute values. Yeah, I think this should get you the points, okay? If anything, just put the changing sign as well if you're in doubt, okay? I think this should be good enough. The scoring guidelines aren't clear. Okay. Identifies interior of interval of convergence. So that's this portion right here. Okay. And then we were checking the endpoints afterward. Okay. So let me see. Consider both endpoint analysis and interval. Absolute value ratio or resolve lack of absolute value. Okay, that's very unclear as to whether you need to show all this or not. But you need to justify your answers somehow that to use the alternating series test, and these are the conditions for the alternating series test. Okay. There's both endpoint analysis and interval of convergence. Says alternating series, these terms decrease in absolute value to 0. So this is, I guess, that. Okay. I would just write this, to be honest, for both of them. Okay. To clearly, honestly, it's just 1 point. Analysis and interval convergence. So it's not the end of the world. I don't know if they give half points. I don't think they do. So take the time to write this, in my opinion. Okay. Part B, show that f of half minus half less than 1/10. Justify your answer. So either we have to use the alternating series error bound or the Taylor's inequality, Lagrange error bound thing. This is an alternating series, so let's try to use that. Okay. So 6b, alternating series error bound. Okay. So how in the world did they get so the f of half minus half? This is the some partial sum, probably. Okay, so how in the world did they get that? Well, f of half, it looks like they just used the first term only. Because f of half is half minus half cubed over 3 plus half to the 5th over 5, so on and so forth, okay? So, f of half minus half, okay, is less than or equal to the first omitted term. What's the first omitted term? That's this term right here. So we plug in x is half. Okay, so that's less than or equal to, that's 1 over 2 cubed. That is 8 times 3, which is less than or equal to 1 over 24. Okay, so, and then we just say that 1 over 24 is less than 1/10, and that should be it. Okay, let's see the scoring guidelines. We had to be able to realize that they just used the first term only in the partial sum. Okay, uses the second term. That's what I did over here. Justification. This is it. 2 points right there. Okay. C. Write the first 4 non-zero terms and the general term for an infinite series that expresses f prime of x. So, remember you can differentiate, integrate power series, so we can just differentiate. Well, we gotta do both, so we can differentiate term by term. So let's differentiate. So f prime of x, just use the power rule. Can I fit it all on screen? I don't think, oh actually I kind of can, okay? So it would be 1 minus 3x squared over 3 plus 5x to the 4th over 5 minus 7x to the 6th over 7, so on and so forth. I don't know if we need to simplify. Let's just do it. It's simple enough. Just be careful. X squared plus x to the 4th minus x to the 6th plus so on and so forth. Okay, this is the first 4 non-zero terms right here. And then let's write the general notation. And equal something to infinity. It'll be, there's a changing sign clearly, right? So minus 1 to the first term, let's start from 0, I guess, okay? N equals 0. So it's positive, right? While the second term is negative. So let's do minus 1 to the n, okay? And then this is even powers, so x to 2n. Okay, and that should be it. Let's double check. N is 0, we get positive, and it will be x to 0, which is 1. Yep. N is 1, this is negative, we get x squared. N is 2, this is positive, we get x to the 4th. N is 3, this is negative, x to the 6. Good. We got an answer right there. Okay. First 4 terms, that's right there. General term, I don't even know if we need to write the summation, but the point is identified by identifying the general term either individually or as part of a polynomial series. Okay, yeah, this should be it. Okay. 60. Use the result from part C to find the value of f prime of 1/6. Okay? So, 60. F prime of 1/6. Did I write it correctly? F prime of 1/6. Yeah. So we probably want to use this one. They didn't say approximate value. They said it's probably exact value. Okay. So let's use this one over here. Summation as n goes from 0 to infinity minus 1 to the n times a 6th to the 2n. So how do we solve this? Well, isn't this a geometric series? Yeah? So, it's first term over 1 minus the common ratio. Okay? So, I mean, if it helps to write it in this one, you can as well. Okay? So what's the common ratio here? We gotta somehow combine this as something to the n. Okay, so honestly, I would approach it from here. So we can use properties of exponents to write this as minus 1 to the n times, what's 6 squared? That's 36, right? So 1 over 36 to the n. Okay, so we can write the summation as n goes from 0 to infinity of minus 1 over 36 to the n. Okay, so this is the common ratio. So this is first term is n equals 0, so plug in n equals 0. So we got 1 over 1 minus the common ratio, which is 1 minus 1 over 36. So this is 1 over 1 plus 1 over 36. Okay? Honestly, I wouldn't bother simplifying from here. Box this. Let's see if we needed to simplify it. Result from part C must be geometric in order to be eligible for this point. If a response inputs an incorrect geometry for a consistent answer. It doesn't say we need to simplify. Honestly, I wouldn't bother to. I would just box this, but we can do it as well. It's not too bad. Okay, this is 1 over 30, this is 36 over 36, right? So 37 over 36, which is 36 over 37. So this is acceptable as well. I would honestly just do that to not risk it. Okay, and that's it for this problem. It was not too bad. You had to be able to, this was probably the hard one, part B. Okay, otherwise, these were other ones were quite straightforward. And this one, you had to recognize geometric shapes, which is not too bad. This one probably was harder though for most people in my opinion. Okay, hopefully this was helpful. Please give this video a like if it was. And hopefully I'll see you in another video as well. Bye.